section of Chapter 6, Growth and Decay. This is where we use what we've been learning about exponentials and logarithms for some real-life situations involving exponential growth or decay, such as population growth or depreciation of a vehicle or something that we buy, or radioactive decay, or something like that. Okay, so here's the formula that we use for everything. The amount of something at time t is found by taking the initial amount times e to the kt power, where k is some constant that we have to find, and t is time in whatever unit we are using when we find k. Every problem in this section pretty much has you find k first, although it doesn't say, sometimes it says find k, sometimes it just says solve the problem, and you have to realize that finding k is the first step. So it's almost like every problem has two problems in one. Okay, so just to clarify, a is the initial amount of something. So if we're talking about a population, it would be the beginning number of specimens, of animals, of whatever in a population before the time we are looking at starts. The final a that we're discovering here is the amount after a certain amount of time t. So it's a function of time. And then k is a constant that you must find. And then t is time, and of course when we did time last chapter, we said that time had to be in years. This time it doesn't have to be in years, it has to be whatever was used to find k. So if you used seconds to find k, then t is in seconds. If you use minutes to find k, then t is in minutes, etc. Okay, we have a growth type of problem, like a population growing, when k is positive. And we have a decay, like radioactive decay or depreciation, when k is a negative value. If you do the problems right, you will automatically get those positives and negatives when you're finding k. Alright, I want to go ahead and give you this formula, although you're not going to use it on your assignment today. It's called Newton's law of cooling. Let me just put that up so you can see it. Newton's law of cooling is this formula here. Let's just talk about it. I just think it's interesting. Sometimes in years past they've had it actually used on the assignment, or it might show up on a final. If it were, they would probably give you the formula. Anyway, Newton's law of cooling says that the temperature of something at time t can be found by taking the room temperature, or the temperature of the oven in which the item is being placed, or whatever is causing the temperature to change, plus the initial temperature of the item minus the room temperature times e to the kt power. Okay, and what this allows you to do is figure out how long it takes a pizza to cool off from a 400-degree oven so it's cool enough to eat, or just things like that. Or there might be problems like how long can you leave chicken sitting out on the counter before it gets to a temperature that it starts to breed bacteria and becomes unsafe. So it does have its purpose. Alright, I'd like to do an example, but I know you like me to keep our notes short. So I'm going to stop this video and keep it really short, and then our next two videos will just be examples of how to use what we've learned here.